Hello everyone, welcome to the signal system class. In this presentation, we will discuss the shifting theorem in jet transformation. This theorem states that if the jet transform of ft is fz, then the jet transform of ft plus capital T will be equal to jet times of fz minus z f0, which will be equal to jet times of jet transform of the function ft minus jet times of the function ft at t equal to 0. So we see here that from the definition of jet transform, we have jet transform of ft plus t is equal to summation n is equal to 0 to infinity of f n plus 1 into capital T into j to the power minus n. Now we will multiply this equation by z into z to the power minus 1, so that we can write this expression as z summation n is equal to 0 to infinity of f n plus 1 into capital T z to the power minus n plus 1. That is, we have multiplied this by z to the power minus 1 and z to the power plus 1. Let this be equation number 1. Now let us substitute the value of n plus 1 is equal to k. So if we substitute the value of n is equal to 0 in this expression, the value of k will come out to be 1, and if we substitute the value of n is equal to infinity in this expression, the value of k will be equal to infinity. Now substituting these values in this equation 1, we get z transform of ft plus t is equal to z summation k is equal to 1 to infinity of f kt into z to the power minus k. So z transform of ft plus t can be written as z into summation k is equal to 0 to infinity of f kt into z to the power minus k minus z f kt into the z to the power minus k at t is k is equal to 0. That is, we have changed the value of k from 1 to infinity to 0 to infinity. So we have subtracted this term from this term, so that we will get the same thing as this expression. So this can be written as z transform of this function. So we can write this as z into fz minus z times of f0, because if we substitute the value of k equal to 0 in this expression, it will come out to be f0. Now this can be written as z into z transform of the function ft minus z times of the function ft at t equal to 0. This is the proof of the shifting theorem. Now let us see the two corollaries for the shifting theorem. The first corollary is that we have to prove that the z transform of t plus 2t will come out to be z square fz minus z square f0 minus z times of ft. So to prove this, we will make use of the shifting theorem. So z transform of ft plus 2t can be written as z times of f t plus t plus t. And we have found out from shifting theorem the z transform of f of t plus t. So we can write this as z times of z transform of f t plus t minus z times of f t plus t at t is equal to 0. That is, we have written the shifting theorem for this expression. This one simplification will come out to be z. Now again we will write shifting theorem for this expression, which will come out to be zfz minus zf0 minus z of ft. This one multiplication will come out to be z square fz minus z square f0 minus z times of ft. So we have proved that z transform of ft plus 2t is equal to z square fz minus z square f0 minus z times of ft. So we can also write the generalized form for this expression. Z f of t plus mt can be written as z to the power m of fz minus z to the power m of f0 minus z to the power m minus 1 of ft minus z m minus 2 of f of 2t minus z m minus 3 of f of 3t up to z f minus 1 of t. That is, total number of terms will be m plus 1, because when it is t plus 2t we get 3 terms. So if it is ft plus mt, we will get total number of terms is equal to m plus 1 in this expression. So this is the generalized form from which we can find out the Z transform of any function. Now let us move on to the second corollary. The second corollary, in which we have to prove that the Z transform of f of t minus nt into ut minus nt is equal to z power minus n into fz. Now from the definition of Z transform, we can write this as summation m is equal to 0 to infinity of f m minus n t into u m minus n into t into z to the power minus m. We have taken another variable m here because the variable n is already in this expression. So we have substituted another variable m in this expression. Now again we have multiplied this expression by z to the power minus n into z to the power plus n, and we have written this expression as shown here, that is, this will be equal to z to the power minus n summation m is equal to 0 to infinity of f m minus n into t into u m minus n into t into z to the power minus m minus n. Now again we will substitute the value of m minus n is equal to k, where k is integer. Now from this expression, if the value of m is equal to 0, the value of k will be equal to minus n, and when the value of m is equal to infinity, the value of k will be equal to infinity. Now we will substitute all these values in this expression. So this value will come out to be z to the power minus n summation k is equal to minus n to infinity of f of kt into u kt z to the power minus k. This will be equal to z to the power minus n summation k is equal to 0 to infinity of f kt z to the power minus k, because we know that this is a unit step function. So the value of this unit step function will be 0 for k less than 0, and it will be equal to 1 for k greater than or equal to 0. So all the terms before k less than 0 will be equal to 0, so that the value of the summation will be from k is equal to 0 to infinity, because all the values less than 0 will be equal to 0. So we find that Z transform of f t minus nt into u t minus nt is equal to z to the power minus n into fz, because this can be written as, this is nothing but this is the Z transform of this function. So the value of this Z transform will come out to be z to the power minus n times of fz, that is this expression. So we have proved that Z transform of f of t minus nt into u t minus nt will be equal to z to the power minus n into fz. So that's all in this presentation.